Hello and welcome back to the lesson 3 in chapter 3. The chapter 3 is about differentiation and this lesson is about computation of derivatives. We are using the power rule in this. Now about this lesson, this is one of the most crucial lesson not only for this term, even for the next term and the coming terms. It is one of the most important thing because derivatives is very crucial. You should not forget this. Whatever you study in this lesson must be thorough. So please make sure you understand these concepts properly and have a very focused mindset when we are doing this lesson. Here, the learning objectives are to find the derivative of a function using the power rule at a given point, and to find the nth derivative of a function, and also to use differentiation rules and higher derivative in solving real world problems. We will look into all these three objectives in this video, and the keywords are power rule, higher order different derivative. Now we will see these one by one. The power rule over here. Before the power rule, let us see this. Can you see a constant line? A constant line can be a straight flat line. Now, what is the slope at any of these points? If I take a slope over here, you can see the slope is 0, right? It's a flat line. The slope is 0. Now, when it's a constant value, say 3 or 5 or any constant for that matter, it can be anything. This will have a flat line, right? At any value c. Now, if it's 5 at 5.5, there'll be at the point 5, there'll be a flat line. So the slope is 0. So whenever you do the derivative of any constant, you should directly write it as 0. But you can do this formula, which we have studied in the previous lesson. You can try this. You can plug this in and try it by yourselves. At a later stage, you can try this definitely, but you will get the answer 0. Now, from this lesson, we are trying to find rules and shortcuts. So now over here, whenever you see a constant, it is 0. That's the first important thing. And now, what about 1? What about x? If x is just a variable, it is 1. Now, if you see the line x, one second. Let me draw just this. What is the slope over here? It would be, it depends, but generally you can take it as 1. Now, when we see the power rule, you will understand why this works. But for now, you just remember constant is always 0 and x is 1. But now, if we look at this here, so this is the thing about x. And now let us imagine we have x to the power n. Any power. Now there is something called power rule. This is done using the previous lessons formulas, the basic derivative formula, and then you can get it. But now if you remember this by heart, that's more than enough. Any power that is there which is raised to x, what happens when you use derivative? D by dx. This is very important. That means you're taking derivative of this. The answer would be whatever is the power comes down over here, and you have to subtract the power by 1. Now let's use a number over here instead of n. If you have to derive, say, d by dx of x to the power 2. What's going to happen? This 2 is going to come down and it's going to be x2 minus 1. So it is basically 2x. That's it. Why? 2 minus 1 is 1. You can write it or leave it. Now let us take another example. D by dx, x to the power 7. Try it by yourselves. Pause the video now or try it by yourselves. If you have a paper, just try it quickly. I hope you realize this. Whatever is the power, it comes down. That goes down over here. So it will be 7x. But don't forget to subtract 1 here. Don't write 7. It's 7 minus 1. So it is 7x to the power 6. This is the answer. What about a huge number? D by dx of anything. Say, for example, x to the power 50. This would be 50x. I'm not going to write 50 minus 1. I'll directly write 49. So as you solve problems, you will realize when you derive it, the power comes down and this reduces by 1. So directly write it out. Now we will see these problems here. Very straightforward. 8 is the power exponent, so 8 comes down, sorry, it's 8x to the power 7. That's the answer. What about this? It's 107 t to the power 106. This is how you solve using power rule. This is how you do derivative using power rule. So the answer is 8x to the power 7 and 107 t to the power 106. Now, the general rule is given like this, but we can even extend this for negative powers or 0 or 1. Let's see now, for example, see this one. How would you solve it? Take a minute, try to pause the video, solve it, try to solve it by yourselves, and then I'll continue. As of now, we have not learned directly how to solve anything in fraction, right? But look over here, we might remember anything down, say power 2, can be written as x to the power minus 2, right? Or if you have 1 by x to the power minus 4, you can write it as x to the power positive 4. What happens when you take from the numerator and put it to the denominator, the sign changes. If it's minus, it becomes plus, or plus becomes minus. Now here we have 1 by x to the power 19. Now remember, this becomes x to the power minus 19. Don't forget the minus. Now we can, derivation of this is same as derivation of this. So let me do the derivative of d dx of x to the power minus 19. Now what's going to happen? Minus 19 comes down. This would mean minus 19 x to the power minus 19 and minus 1. So this is going to be negative 19x to the power minus 20. Why did I increase it? Because negative, you need to add it up. Minus 19 minus 1 will become minus 20, and that is the answer. So this is how we solve the first one. I hope this is clear. It will be negative 19 x to the power minus 20. What about the next one over here? It is root, isn't it? Now, what is square root x in terms of power? I don't want, square root x, like this in radical symbol. I want it in terms of exponent, power. What it is? You might remember it is x to the power 1 by 2. It's half. So now actually over here you might have noticed this is 2. If there is nothing written, it is assumed to be 2. Now if I have cube roots, say for example 3, here you can write it in fraction. Just whatever it is, you just write 1 and then this is divided by 3. This is how you do it. But now what if it is x power 2 over here? You write it here, it's x power 2. X power 2, 2 is to the power, right? You should just, instead of 1, this becomes 2, but because it's power 2. Here, if it's 1, it's 1 divided by whatever is outer. Now, here, if I change this to say 5, it's going to be 5x divided by 3. So, always remember which is out of the radical is below, and whatever is inside the variable, the power, that is, remains as it is. So this is how we can solve it. Now if you have anything, say 5 and x to the power 6, it is going to be x 6 by 5. So this is how you solve it up. Now over here we have got square root, that's cube root, sorry, because it's 3, and x square. This is going to be x square itself, whatever is inside as it is, but this is always divided by the power. And now, can't you use the power rule? Whatever is in the power comes down. So here, let's derive d by dx, x to the power 2/3. Now this 2/3 is going to come down to be the coefficient 2, 3, x to the power 2/3 minus 1. Now we can use calculator over here if you're getting confused, 2/3 minus 1, but you know it is a simple expression. Minus 1 and plus 2/3, that would be negative 1/3. So it's 2 by 3 x to the power negative 1/3. This is the answer. But now what if you want to write it like this in terms of square root? I can't have negative, so what I do is basically we take this negative exponent down. So what happens? It's 2 by 3. You can write this fraction coefficient separately. Here it becomes 1 by x to the power 1/3. Now I'll just write it over here. This can be written as 2 by 3x to the power 1/3. Now what happened over here? This is just the power rule. 2/3 comes down, 2/3 minus 1, and I got 2/3 x to the power negative 1/3. This is your answer over here. Whatever you got over here in this step is your answer after using power rule. But what if this answer is not there in the options to select? If it's writing, this is yes, correct answer. But what if this is not there in the options to select? Then they might be simplified it in terms of this. They have cube root or square root. What do you do then? Then first of all, you can't have negative exponents, so you take it to the numerator or denominator and change its sign. So over here, since it's a numerator, I take it to denominator, it becomes positive 1/3. Next, can you see this 2 by 3rd x power 1/3? Here, this part, I can write 2, 3. This x power 1, I will write over here, x. This 1/3 is basically cube root. So this would be the answer. It is 2/3, 2 by 3 cube root x. That would be the final answer. You can see here. Okay, now over here they have not written it. They have stopped over here at this part. But it's always important to know this step. Why I'm doing this step? Sometimes if it's options, you may not have this particular option in your exam. This might be there. Because I remember many instances the options will be having this method, and then I don't want you to struggle and think what's happening. Just remember, you can simplify this. Negative 1/3, take it down. It would be 2 by 3 x to the power 1/3, and then you can write it as cube root, because 1/3, once again, because x to the power 1/3 is cube root x. Okay, so that's the 3 outside the radical symbol, and that was the answer. Here it's just simplification. Now you have x to the power pi. How would you derive this? We know pi is 3.14, but instead of that, generally when they're asking you to derive such things, they just expect you to keep it in terms of pi itself. Whatever is the power, the pi comes down, pi x to the power pi minus 1. This is it. This would be the answer. Okay, that's it, a single step. That's how we use power rule generally, and we can solve all this different type of problems. Now then, what if you have two terms either added or subtracted or multiplied with constants? What do we do? So if it's added, you derive. If two terms are added and then you have to differentiate over here, just derive each of them separately. Whereas if it's subtracted, do the same thing separately. And if it is multiplied with constant c, then what you have to do is derive only the term variable. Constant remains. What it means is, if you have 2 to the power x power 4, 2x to the power 4, sorry. Leave this 2 as it is. This constant remains. Only derive x to the power 4. d by dx, x to the power 4. Whatever is the answer, just multiply 2 at the end. What is x to the power 4? Sorry, this is x. Now, okay, over here. This is x over here, x to the power 4. So what happens is, 2 as it is, this 4 comes down, 4x to the power 3. Now don't forget to multiply 2 inside. It's going to be 2 times 4, 8x to the power 3. This is the answer. So basically you have left the constant term as it is. Now we will see one by one. Now you have to derive this function, and you have plus and 2 variables on each side. What do? It's very simple. Just focus on the first one. Now there is a shortcut to solve whenever you have constants. Instead of writing 2 multiplied by 6x power 5, you can just multiply 6 with this term. See, this comes down and it multiplies with 2. So 6 times 2 is 12. I'll directly write it. X to the power 6 minus 1 is 5. Direct solving. You need to enhance this method, like, I mean, you need to be thorough with this direct method because that is going to save a lot of time. You have to use this in exam, otherwise you won't be able to solve it quickly. Now, what about this plus 3 x to the power half? Now, this is done. Left side is done. Only this side is remaining. This is going to be 3 multiplied by half x to the power half minus 1. So 3 and multiplied by half will be 3 by 2. That is 1.5. And what else over here? X negative half. This would be your answer. And here it was 12x power 5. This would be the final answer. You can see over here. Now 12x to the power 5, 3 by 2. Now since this is x negative exponent, you can take it down. Only thing is it will be 3 divided by 2x to the power positive half. Now instead of x power half, you can write it as square root x. And this is the answer. Same thing. This is also the answer. Sometimes the option will not be as such. You can see over here x to the power negative half can go down as positive half and then become square root x. This is it. Now please do try this. Pause the video and try this, and then I will continue. We have not come across a division for derivative division and stuff. For now, you can look over here. There is x, x and root x. So we know we can solve, if it's plus, we can individually solve them easily. So why don't you just split this x, distributive property, x to the power 2 by x minus 3x by x plus 2 root x by x. So how about this? You have separated all these x's. Now let's solve it. I will change the color. Let's cancel this x and this goes, square goes. Only you're remaining with x. This and this cancels off. You're remaining only with 3. And what about this? Now here I'll write 4x minus 3 plus, remember this is 2x to the power half divided by x. So this is basically 1. The rule for exponent is when you have numerator and denominator with the same base but different exponent, you subtract. It's division, right? Division is subtract. So 4x minus 3 plus 2x to the power half minus 1. And what is the answer? It would be half minus 1 is negative half. That's minus half. This is the answer. Now you need to apply the derivative. So I will write it up over here. This simplified would be 4x. See, x divided, it's direct. Minus 3. This cancels. And this would be plus x power half minus 1 would be negative half. It's 2 to the power x negative half. That's it. Now then, let me just derive this. This was the simplification what I did till now. I did not derive it. Now let me dy by dx this, that is derive this. So when I derive this, what is going to happen? Sorry for that. Okay. Now here, when I derive it, this x is power 1, right? Now imagine if you have x to the power 1, derive this. D by dx would be, 1 would come over here, x to the power, how much? 1 minus 1 is 0. Anything raised to the power 0 is 1. That is 1 times 1, it's 1. That is why whenever you see x power 4x or x power 1, any case, just write what is the constant. Just write this number. Why? Because this x power 1 becomes 1. 4 multiplied by 1 is 4 itself. So just write this number. When it is a flat constant, minus 3, it's a flat line at minus 3, right? And now that is not an exact flat line. Now imagine it was a flat line like this. The slope is 0. So you just, this dissolves. Why? Because it will be plus 0. That's the same thing, 4 itself. This gone. Plus 2. Now, how would you solve this? Multiply negative half down and x to the power negative half minus 1. This is very, very important. Why? Because you have negative power comes down, and then negative, it adds up. It will be 4 plus this 2 and this 2 cancels. But remember, this negative sign remains, so it will be minus, for minus x to the power 3 by 2. Sorry, minus 3 by 2. Why? Because negative 1 minus half. When you add it, it is negative 1.5 or it is 3 by 2. That is how we solve it. Okay. So that would be the final answer. See, this is at 4. No, sorry. Derivative is over here. It's 4 minus x negative 3 by 2. That is the final answer. First, you need to divide x on all the three sides, and then you will get the simplified form. And then you need to derive this, and then you finally are remaining with 4 minus x power 3 negative 3 and 1.5 or 3 by 2. Now we will move on to the next problem here. Find an equation to the tangent line to graph for the graph of f of x given over there at x equals 1. Now if you recall, in the first lesson we have done the similar problem. Now you need to repeat over here the same procedure. But this time you're not going to use the formula for derivative. We are going to use direct derivative. Let's solve this derivation. So what do we do here? Derivation means f dash of x. That would be 4 is a constant value, so it's 0. So let me just write properly. 0 minus x is a single variable, x to the power 1, so that dissolves to 1, and over here you're remaining with minus 4 plus this c over here 1. It comes up. What happens? 2 to the power x minus 1. Now you will have to solve this. How would you solve this? It would be negative 4 plus this negative 1 comes down. It would be negative 1 x to the power minus 1 minus 1. Negative 4 minus 2x to the power minus 2. This would be your final answer. What happened? I applied power rule over here. When you apply power rule, the negative 1 comes down as the coefficient, and you need to subtract the power by 1. So you have minus times 2 is minus 2, and is for minus 2, x to the power negative 2. That would be the final answer. For the slope only, this is the slope, see? That is f dash of x. That's it. That's the slope. But now they want the equation for the tangent line. I just got the slope, that is m value. M is given now. 9 minus 4 minus 2 x minus 2. Now what? Sorry. 4 minus. I don't know why I wrote that. Okay. Now, what about the tangent line? If you recall, we had the formula for tangent line y equals, now that was, okay, y 1, I believe, plus m into x minus x1. So whatever is given over here, consider it to be x1, and now here you got the x1 value. Then all you do is substitute the x value as 1 and find y1. So here it would be x1 as 1, so I will just substitute what I know. So this is 1, and how do you find y1? All you need to do is substitute this x1 in this equation. So this is f of x or y. So y1 would be 4 minus 4 times 1 plus 2 by 1. So the answer over here would be 4 minus 4 plus 2. The answer is 2. So that would be y1, 2 plus x must be x, y must be y. What is m? This is very important. Now what is the x value given? It's 1, right? So just substitute this over here. Negative 4 minus 2 into 1 minus 2. So this would be the answer for m. You can just put it in the calculator if you want. Now Here it's negative 4 minus 2y, because 1 to the power anything is 1 itself, it does not change, so the answer is minus 6, so m is minus 6. So this would be the equation for the for this particular tangent line. Here let's see. Now, this is another form over here. The 2 is in the other side and minus 6 times x minus 1. But generally in your exam, it's better you write this at the right side. Okay, this is one of the formula. But the formulas can be different. Or sometimes what happens is you should write mx minus x1 plus y1. This would be at the end. That would mean it would be minus 6 into x minus 1. And then we add this y1 this side like this. It's up to you, but anyways, this is the answer. You can see the option and one of the way will definitely match, and that's how you solve it. Now if you recall in the first lesson, to solve a simple finding equation to tangent line, we struggled a lot with huge formulas, but remember, you can solve all those problems easily with this derivative method. And only the thing is, you should know this equation of tangent line and you just substitute it back. That's it. Now then, there is something called higher order derivatives. Now this is one very important thing. Why? Because first of all, I want to mention this Leibniz notation. And higher order derivative means deriving more than once. You can keep on deriving few number of times, And the thing is, the funny thing about the derivative is it's just not slope of the tangent line, or it's just not the slope. You can get a lot of different information as well. You can derive velocity, derive acceleration, position and stuff. We will see that in a while. Now here at the right, you can see Leibniz notation. This is a very crucial thing. Leibniz is a very famous scientist. Now, what did he do is, he found derivative on his own as well. Now, Newton is one of the main founder of derivatives, but Leibniz also found it by his own. He did not, take it from somewhere else. He did it by his own. So, in respect of that, we write these notations d by df by dx. Df means the function, okay? So, or d by dx. In his memory we do that. Now he had used it that if you're deriving it more than once, then you square it, d square f by dx square, and so on, it continues. So now if you see d square, that means it's the second derivative. If you see 4 over here, d4, it's the fourth derivative. Or you can just write it like this: y dash means first derivative, f dash of x. If you write double dash, that means second derivative. Triple is third derivative, and then more than 3, it will be 4, 5, 6 or 7. That is what it means. Now here, the fifth derivative, the order is 5. That means you're deriving a given equation 5 times. Now we will see what this means. Like, we will see a problem here. Now they have told compute as many derivatives as possible, how much you can. So let's first start. Here, when you're deriving it one time, f dash of x, or you can write d by dx, what happens? This 4 comes down and it multiplies with 3. 4 3s are 12, x power, this power reduces by 1. 3 minus 2 and 2 is 4. X, sorry, it's not square. Now my bad. 2 comes down, it's 2 and 2, that's 4. X to the power of 1, so I'm not going to write it, plus 0. Now this is only the first derivative. You need to do the second derivative now. They have told as many derivatives as possible, right? So this means it's going to be 3 times 12, that's 36x squared. Sorry, minus 4. Why? Because x dissolves power 1, it becomes power 1. And then we will continue again. We will start with f triple dash. Now, what happens over here? You need to again derive this. This power 2 comes down. It'll be 72x power 1 and this 4 is gone. Now, we can go to the fourth derivation, f4, x to the power 4. And here, you will just get 72. Why? Because this is power 1, it dissolves. And lastly, f phi x of phi, here it would be 0. Why? Because 72 is a constant number. When you derive any constant, it becomes 0. Over here, there was x to the power 1. When you derive x to the power 1, it becomes 1. I mean, whatever the number it is. So here it was 72x. Then next it was 72, and then it's 0. So these many derivatives can be done. You can see over here, we have written 5 derivatives. That is the thing. Okay. So now we can use this formula. I mean, over here to write this, not a formula. If we just go back here, Leibniz notation, we can use writing Leibniz notation and for anything greater than phi. Whereas here, all you need to see is this one. This is fifth derivative, or this is third, or this is first, and so on. This is how you basically do it. You keep on deriving. Derivation. You keep on doing derivation. Ultimately, you will be landing up with 0. So now we'll go to acceleration. Now, the things like acceleration, instantaneous velocity change, all these here. These are all related with derivative. Yes, this is all related to acceleration, velocity, all physics related stuff, or derivative. Velocity, position, and everything. But these are all indirectly related with derivative as well. We will see what it means. You can go through this later on. Now, if you have acceleration, then how would you get acceleration? You need velocity. Derive velocity, you get acceleration. So whenever if you have been given a velocity function, you basically derive that and then you find the acceleration. And now here we will see a problem. Suppose that the height of a skydiver t seconds after jumping from an A plane is given by this particular thing, f of t equals 640 minus 20 minus 16t square feet. Find the person's acceleration at time t. So how do we do this? Now wait, please try pausing the video and try by yourself, and then I'll continue. Here it is so simple. You should just see what is given to you. If you look carefully, the height is given. That is the position, the height, right? So velocity v of t can be found out by deriving the height. That is, if I take s as position, derivation of that. So what happens here? I have the function f of t. That means derivative of f of t is required. So how do we do the derivative here? 640 becomes 0 minus 20 because t becomes 1 minus 2 comes down, it will be 32t. And this is the velocity. What about acceleration? Acceleration with respect to time is the derivative of velocity, and the answer over here would be, again derive this, it becomes 0 and minus 32. That would be the answer. So you can see over here, the first one was, oh no, that's it, acceleration is minus 32. Now what about the units? Here they have told in feet per time is seconds, t seconds, they have told seconds square. Now one important thing to understand over here, feet per second square. Why? Because it's acceleration. If it was velocity, it would be just feet per second. So this is the answer, minus 32 feet per second. Second squared, sorry. So that's it. Now that's it for the lesson as well. I thought there was one more. So you can see that derivative, you can use a lot of real world problems, a lot of different applications. But the most important thing is this is the basics. As you're thorough with this, you can do this quickly. Then you can move on to the more complicated ones, because this is the base and you cannot forget this. So make sure when you go through the video, you study this for a long time, for not only this term, even the next term, just not for the exam, for other purpose as well. So make sure you're thorough with this lesson and then the other lessons will become easy. So solve more problems, solve extra problems by yourselves, and then you can understand it easily. I'm stressing on this lesson. Why? Because you will realize this lesson is even used until the term 3 exam. Okay, so I mean this concept is used. So I hope this has been useful. Please do ask any questions you have in the comment section. If you're not yet subscribed to my channel, please do subscribe to it. It would mean a lot to me. Until the next video, have a good time. Bye bye.